Okay, Bismillah ar-Rahman ar-Rahim. After understanding or knowing the proton number or nucleon number, which we name as a mass number or atomic number, let's see and discuss in detail about the first 20 elements. Okay, so what the composition in these atoms and how we can represent them and how we can find out and how many number of proton, electrons and neutrons are present in them. So let's start to see them. Here you can see that the first element is hydrogen. Even you can see in the periodic table, the hydrogen also first element that is present in the periodic table. Okay, so that will also help you to understand more about the periodic table too. The symbol of hydrogen element is H. Understand? That is written in front of you, capital H. It's mentioned here that it has only one proton. It means its proton number is 1. We know that protons are always equal to electrons. It means electron is also 1. But look what's going on here. This one, 0, mean to say in an hydrogen atom, in the nucleus, there is no neutron. Understand, my dear? This point clear?
Yes.
Okay. So when we're going to see the nucleon number or the atomic mass number, we will find here only 1. Why? Because in case of hydrogen, there is only one proton and no neutron. That's the reason 1 is the answer. Is it quite easy or not?
Yes. Yes.
Okay, Alhamdulillah. Now come towards the second example, that is about the helium. This is the second element that is present in the periodic table. Okay, what's going on? Its symbol is He. H is capital and E is in lowercase because it is a rule to write a symbol if any element you represent the symbol, if it has 2 letters. So according to the rule, the first letter should be capital and the second will be in the lowercase. Okay, my dear. Here, in case of proton in helium, there are 2 protons in helium atom. And you know that number of protons is equal to number of electrons. It means 2 electrons are here in helium atom. Now, the third thing, what it's going to tell you, the neutrons, these are also 2. Okay, so now 2 protons plus 2 neutrons. In case of helium, the answer will be equal to 4.
4.
Very nice. Easy?
Yes. Very easy.
Okay, now it's time for your test. A small assessment. Why in case of lithium we have 7 nucleons number? There, lithium, 3 protons, 3 electrons, and 4 neutrons. Understand or not?
Yes.
How?
Proton electron number 3 and 3 should be 6.
Okay.
But it's 7.
Why you adding here? This, my dear, this is only for this. If you know the proton number, it means electron will be the same like this. They are similar. I make here minus. Okay, or equal. But this is not equal or may be equal sometimes. Okay, this may be equal or may not be equal. That's the reason in case of lithium, my dear, you will see that there are 4 neutrons in lithium. Okay, same like sodium. If you remember, in case of sodium, how many protons? There are 12 protons. That's the reason it's 23. Otherwise, proton and neutrons are equal in both. So these protons and neutrons are, electrons are equal in every element. Okay? This point okay or not?
So it will be like 3 and 4 is
I can't hear you. Can you speak again?
like 3 and 4 is
Yeah, 3 and 4. So if you're going to find out the nucleon number, this is 3, yani number of protons, plus number of neutrons, this 4. So that's give you 7. Okay, that's the reason lithium nucleon number is 7. Okay, this whole table is like this. Understand, my dear? Let's move to the next topic.
yes.
Okay. So if they are same, no problem. Like here, this equal to this. That's the reason you plus this and this, you will get 14. But in case of this, it is not equal to electrons or protons number. Sometimes maybe more, sometimes this may be less. So there another thing we will discuss, that is about the isotope. Okay, now let's move to the next part of the lesson. Now, so the number of protons and electrons increase by 1 at a time and are always equal. That just I explain you. What do you notice about the number of neutrons? They are not like this. Okay. So this again, your little bit small assessment. You can take the screenshot, and almost 6 questions are here. You try to find out their answers. Very easy. Name the particles and make up the atom. So you know the particles. What are these? Yani proton, electron, neutron. Which particle has this a positive charge? Who has a positive charge? Yeah. Please reply quickly. In an atom, which particle have a positive charge? Hurry up, Amro. Even type in the chat. Yes.
Hadri.
Auzubillah. Which particle? I don't tell you, I don't ask you about the atom or the element. I'm asking about a particle, the subatomic particle. Amro, what about you? Quickly reply. It was not a difficult, Yahi. What are you doing, guys? It's mean you didn't understand anything. Yeah? Yes, please. Ahmad, why are you not replying? Amro, what's problem with you?
And there is some but forgot.
If you understand, then you need to reply me. What's this? I just explain you here. It's a difficult thing. Look, even not 30 minutes gone and you don't going to reply me. It's not good. If you do like this, you will not understand anything. I just explain you here, even that a chart. Focus on the screen. Look, proton. Okay? Proton unit 1, positive charge. What is this? Is it a difficult thing?
No.
So why you not replying me? In front of you it's written, maybe million time I explained you here. Look, proton, positive charge, and you are not telling me. Please, my dear, focus. Please focus. Okay? And try to avoid all the gadgets, the smartphone or anything that you have. Don't use this. I continuously listening that the messages are coming there and it's all the tunes are coming, and especially from your mobile. Ahmad, Amro, are you with me or not? Yes, please. Alhamdulillah, you reply now. Thank you. Now, so an atom has 9 proton. Which element is it? So you can easily find it here. It means I will prepare after that solve this from you here. Now look, if an element has how many protons or electrons? 9 protons. Look here. Where is the 9 proton? Here. This one. Yeah. This 9 proton. So which element is this? That is fluorine.
Fluorine.
Okay. Now, I don't know why you make me angry today. Okay, so why do atoms have no overall charge? Very easy, because equal number of protons, equal number of electrons, they're going to cancel each other. So overall, no charge. What does this term mean? Proton number, nucleon number. Yes. Who tell me about the proton number? What does it mean? I will not go next if you're not going to tell me this.
The number of proton.
Very good.
Which is the
Very done.
number of
Excellent. Alhamdulillah, now you reply me. A correct answer. And what is the nucleon number? Yes, please.
nucleon number is like electron.
No. Here you're going to make a mistake again. Look, that is the nucleon number. What is nucleon number? Yes, proton plus neutron. This is called nucleon number. Okay. So here you can find in each how many protons, electrons, and neutrons are there. Now, can you solve this? Even you just the oxygen that I solved with you. Okay, in the case of carbon, you can. So that is your as an assessment, small or homework. You need to solve them. Okay. Okay, now we move to the next topic. Very important part of the lesson. Mostly 2 to 3 marks. The examiner in every year asks from this topic. Okay. So be attentive in this one. That is the isotopes and radioactivity. What's the mean by isotope? How do identify an atom? A reminder. So here it's going to tell you only sodium atom has 11 proton. You can identify an atom by the number of proton in it. We know very well. But what is the meaning of isotopes? So please, my dear, focus here and try to understand this thing. Look. All carbon atoms have 6 protons, but not all carbon atoms are identical. How? Is it possible? There is also 6 proton, 6 proton, 6 proton. It's mean protons are always equal to electron. Mean to say 6 proton, then 6 electron also. But it's going to mention here, it's not identical. Okay, let's see what's the difference. Some have more neutrons than other. Look, here you have 6 neutrons. Here in this carbon atom, 7 neutrons. Here in this carbon atom, 8 neutrons. Now, what we understand from this? Most carbon atoms are like this with 6 neutrons. They make 12 nucleons, yani proton plus neutron. So it is called carbon 12. Why carbon 12? Because its nucleon number is 12. In this case, you can say this case number 1, this case 2, and this case number 3. In the second case, what you will find? But about 1 in every 100 carbon atom is like this. If you have 100, then you will find 1 carbon that have 7 neutrons. Okay, this thing. Then 6 plus 7, the answer is 13. Okay, so this is called carbon 13. Even you can see this carbon 13 is written here. 12 is written here. Now in case 3, you will find One more,
like,
sorry,
and six is the
yes,
look.
12. But here, in every carbon atom, one neutron is more. One neutron is more. Okay. So this one is the carbon 14. You can find here, it's 14. Understand? The three atoms above are called isotopes of carbon. If an element or atom show this kind of nature, we call them isotopes. What we call them?
Isotopes.
Isotopes. So that is the definition of isotope. Isotopes are atoms of the same element. Element is same. Why? Here is carbon, here is carbon, here is carbon. Okay. So same element, but different number of neutrons. Here number of neutron, 6. Here number of neutron, 7. Here number of neutron, 8. So these are called isotopes. Any question in this topic?
No, sir.
Easy?
Yes.
Okay. Now, let's see. Most elements have isotopes. For example, calcium has 6, magnesium has 3, iron has 4, and chlorine has 2. So few elements it's going to mention here. They have their isotopes. Okay. Some isotopes are radioactive. What it's mean? Do you have any idea about radioactive or
They have
radioactivity?
radiation.
Very nice. Excellent. Radiations. Now look here. Now what it's going to tell you about the carbon 14 atoms behave as a strong, strange way. How? It is a radioactive, mean to say the radiations are coming out from them. That's the reason we call them radioactive. That means the nucleus is unstable. Sooner or later, the atom breaks down naturally or decay, giving radiations. Okay, in the form of rays and particles plus a large amount of energy. When this carbon 14 atom start to decay or the radiations are coming out, a lot of or huge amount of energy is coming out. Like carbon, a number of other elements have radioactive isotopes or radioisotopes. So if any isotope who give radiations, we name as radioisotopes that occur naturally and eventually decay. What it means decay? It will finish, it will not more. But the other two isotopes of carbon, like most natural isotopes, are non-radioactive. What it means? There are no radiations are coming from them. Understand, my dear? It's easy.
The the other two isotopes of carbon.
Yeah, they
What are
don't. Yeah, they are not participate in any kind of radioactivity, or you can say that they are not able to give radiations. Okay. Now, this is very important part of the lesson according to the radiations. You know to memorize these things, okay? Alpha particles. What are alpha particles? Millions times you heard the word about the alpha particles. Made up of 2 protons and 2 electrons. If in any substance or any species that has 2 protons and 2 electrons, this is called alpha particle. Okay. Will you remember this?
Yes. I'll
Number
write
2.
it down. I noted this.
Yeah. Number 2. What are the beta particles? You can take screenshot even, no problem. Electrons moving with high speed. Only the electrons, when they move with very high speed, we call them beta particles. And what are Gamma rays, high energy rays, we call them gamma rays. Okay. And about the neutrons, you know very well. Okay.
Wait, teacher, I'm not.
Okay. Okay. Well done. Now here a little bit, you can say that the information about the decay in the random processes. So you just try to read this one. Hope you will understand this thing. If not, then I will explain you, because it's not as a part of this, it's just an extra information. Okay. Radiation can harm you. How? If the radiation from radioisotopes get into your body, it will kill body cells. Okay. A large does cause radiation sickness. Victims vomit a lot and feel really tired. Their hair falls out, other their gums bleed, and they die within weeks. Even small dose of radiation over a long period will cause cancer. These are the radiations that from different isotopes or radioactive isotopes, if accidentally falling on you and you are not aware it can cause very, very dangerous effects on your body. Even the treatment during the cancer, you know very well, there is a chemotherapy. What happened in it? Sometimes
And kill the
yes, very good. They also treated this, the, you can say that the carcinogenic cells, they are present into the body. They are going to kill these cells with the help of these radiations. Okay. But these radiations are controlled. They know that which part of the body they need to strike or hit or kill these cells. But after too much care, you know that the person who is suffering from this disease, many times he lost his hair, and even the teeth start to bleed, and he or she feel very weak, because this affects damage the other cells too, but it's too controlled way. Understand?
yes.
Okay, now let's go to next part, making use of radioisotopes. How you can use them in your routine life, and how you can get advantages from them. To check for leakage, very important part. Engineers can check oil and gas pipes for leaks by adding radioisotopes to the oil and gas. If a Geiger counter detects radiation outside the pipe, it means there is a leak. What is a Geiger counter? It's a special type of instrument device that only can detect these radioactives.
Radiation.
Yeah, so the radiations will detect it. So the radioisotopes used in this way are called tracers. Mean to say, at a very minute or small amount. To treat cancer, just I explained you about this. Radioisotopes can cause cancer, but they are also used in radiotherapy to cure cancer, because the gamma rays, you know very well what are the gamma rays. In radiation, kill cancer cells more readily than healthy cells. Cobalt 60 is usually used for this. You should know that which elements, isotope or radioactive isotopes you used in this one, that is cobalt 60. Why we write here 60? Because its nucleon number is 60. The beam of gamma rays is aimed carefully at the site of the cancer in the body. My dear, this you understand? Yes.
Yes.
Okay. Now the next part is here to kill. Yeah.
Okay, why is it called cesium 137?
Where you were reading about that? I just read about the
I
cobalt.
think this because 60 is
This the cobalt 60.
yes, the 60 number is from the
Yeah, the number of proton plus number of neutrons, that is equal to 60. Okay.
okay.
Maybe there are many other isotopes of cobalt, but this one we used. Okay, to kill germs and bacteria. Germs rays kills, sorry, gamma rays. The gamma rays kills germs too. So they are used to sterilize syringes and other disposable medical equipments. They are also kill the bacteria that cause food to decay. So in many countries, food like vegetables, fruits, spices, and meats are treated with a low dose of radiation. Again here, cobalt 60 and cesium 137 are used for this. Another use of radiations, carbon dating, very important part. Many times this question was asked in the exam. So carbon dating are bodies containing some carbon 14 take in the food. When we die, we take no more in, but the carbon 40 atom continue to decay. So scientists can tell the age of the ancient remains by measuring the radioactivity from them. This mummy was found to be around 5,300 years ago. Understand, my dear?
Yes.
Okay. Now, come towards the assessment. What are isotopes? Who will going to tell me now? Yes, please. Hurry up. What are isotopes quickly? Wallahi, very easy.
Teacher,
Yes,
each or two of the same element or something like that.
yes. You, Amro, very nice. Excellent, my dear. How? If an atom has same atomic number but different nucleon number.
The same number of proton, different number of neutrons in
Yes,
the nucleus.
very nice. Excellent. We name them isotope. Name the three isotope of carbon. You know very well. Carbon 14 is a radioactive. What does that mean? You know it can emit radiations. Yeah.
Yes.
Okay. Thank you very much, Amro. I'm very happy when you replied me. What is radioisotopes? Give two examples. Radiations can kill us. Why? You know very well it can kill the cell, damage the
Yeah.
cells. So why? Very good. Why are radioisotopes? Sorry,
Radio
Answer
is
question B.
one by one. First, Amro, you.
radioisotopes helps to kill the cancer cells that are treating the body and destroying the body. So yeah.
Yes. Okay. Well done. Yes, Ahmad.
They are used to treat cancer.
Very,
It kills the cancer cells in the body,
well
but it
done.
can affect
Excellent. Great.
vomit
Radio.
and yes, hair.
Well done. Very nice. Okay. Alhamdulillah. Now, mashallah, you understand. You just try to just shoot my blood pressure. That's the reason. Now, after that, you are replying very well. Okay. Radioisotopes can be used to check pipeline for leakage. Yes. Explain how this will happen. You know very well. how could you tell the pipe had no leak? If there is a Geiger counter will show you 0, it means there is no leakage. Okay, spices and shipped all over the world and are often stored for a long period of time. Yes, you know, they are usually treated with radiations and to kill the germs or the bacteria. Name 2 radioisotopes used for this. So they are written even, you know, very well. Just let me to stop the meeting. So recording, then I will talk to you. Okay.
Okay.